So, turn the lights down.
Probably won't trigger. You let me know.
So all of you hovering over there, you need to come over here. You won't get credit, right? So I think it's a couple minutes after 7. I'm Diane, for those of you who don't know. I'm the library director here. And Dr. Peck is here via Cornell, NASA, and back at Cornell. He actually teaches at my alma mater. I was a mechanical engineer many years ago at Cornell. Yeah, you didn't know that. So it's very exciting. It's a whole new school over there. It's a very different place. One of the things that this library is very pleased to participate in is NASA at my library. So we've been taking a lot of programs to outer space this year, and we'll continue to do that for a couple of years. So we're very excited. I don't know if any of you went through your classes or anything and did any research about Dr. Peck, but he was chief technologist at NASA for 2 years, and there's only 9 people in that. 9 people that reached that level in the staff, so it's pretty exciting. Did some exciting stuff, and now he's doing all he can to leave the Earth. Thus, the Build Your Own Spacecraft, and he has a great TED Talk on packing for Mars as well that I encourage you to go and watch. So one of the things that you have to do is find a seat and sit down, unless you're really going to stand the whole time. We have a calendar of events here if you're interested in anything else going on. And we also, as in most events, have a survey. So I'd like you, when we're done, to grab a survey and a pencil. Just take a few minutes. It's 5 easy questions. I need to submit them to NASA. So I would appreciate that help from you.
So I really think there's plenty of space here.
There's plenty of
Why don't you take a
room.
couple
You don't
minutes
even
before we
have to
start
sit
and-
on the floor.
Grab a chair, scoot those back, it'll all be done.
And yeah, we highly encourage you to come sit. Much more comfortable for Dr. Peck. And when I turn the lights out, no one can go to sleep. You do have to write something about this, right?
Absolutely,
Yeah, so. Perfect. Everybody
Thought you were in the
set?
front row. All right.
All right, I think we're good to go.
Okay, well, thank you so much for coming. I'm just super excited to be here. I came across this library when I first moved to Ithaca, and it's just so charming. It's the perfect town library. It reminds me of the one in the small town where I grew up. So it's great to be here, and thank you so much for taking some time out of this really cold evening to talk about some space things. My plan is to talk about how to build your own spacecraft, which I don't necessarily mean as here are the instructions that you shall follow. This is more of a philosophical talk. It's more about a trend that exists these days. The trend is people trying to engage in science and engineering on their own without necessarily the help of NASA or big companies. The way the world has gone with the growth of consumer electronics and the fact that you can hold a computer in your hand, all these changes mean that you can participate in science in a way that was just not possible, even 5 or 10 years ago. So that world has changed. It's sort of slipped out from under us in an interesting way. And I'm excited to tell you what I can about that. I'm glad to answer some questions too. So let me first invite you to please interrupt me as I'm talking. If you have something you'd like to ask me, I'm glad to just do that. Also, if it gets really boring, I have some swag here. I'll ask you some questions. And I will give you a prize as a result. It could be a sticker, or it could be a Space Shuttle Program badge. So look out for that. Let me talk a little bit about science and engineering. So some of you are from an astronomy course at the high school, right? Let me offer this distinction. Scientists discover and engineers create. This is roughly a quote from Theodore von Karman. He started the Jet Propulsion Lab, which is part of NASA, the part that does things like this, Mars rovers. This is one of the first pictures taken by the Curiosity rover in August of 2012 when it landed. this little logo right here, that's kind of a cartoon picture of the Curiosity rover. This little logo is made for the camera to sort of orient itself and calibrate itself. So back when JPL, the Jet Propulsion Lab, was planning to build this rover, they thought, we're going to put a big JPL logo here so that the first picture from Mars has JPL on it, and because they're proud of what they're doing. NASA said, no, this is a NASA project, not a JPL project. You're going to put a big old NASA picture right there. So they went back and forth, and they decided to not really do either one. They just have this picture of the rover, which is all well and good. The engineers, though, who have spent countless hours, 80 hours, weeks, for multiple years, trying to design and build this rover to be successful, and it was. It has been, continues to be wildly successful. That wasn't enough for them. So what they did, the treads, you can see the tire tracks here, so to speak, from the treads on the rover, right? There are little holes in the treads that spell out in Morse code JPL. So whenever the rover is rolling around, it's writing JPL, JPL, JPL all over the surface of Mars, tagging the surface of Mars with their gang sign, which is kind of a neat idea because they're taking ownership of this thing. It's an accomplishment for them. They're proud of it. They want us to know that they built this thing. What's your question?
Was this discovered by NASA or did JPL just tell the world?
Oh, it was not really a secret. It was not something that was publicized either. But I'll tell you, every inch of this rover and every rover that NASA or JPL have ever designed and built or operated, everybody knows every detail of what's going on. So there's not really possible to hide something like that. It was allowed to happen. And it's geeky enough that only a group of people like this would actually appreciate what's going on. Anyway, I use this to explain something about science and engineering. So scientists discover the world that is. Engineers create the world that never was. It's not that one is better than the other, but they're different. I've had a lot of students come to Cornell wanting to study the planets and enroll in aerospace engineering and become disappointed. Because that's not what we do. We come up with ways to discover the planets. Or I've had students enroll in the astronomy program at Cornell, hoping to build rockets. That's not what the astronomers do, right? They look at stars, they look at planets, they discover things. So, which are you? Are you a discoverer or a creator? And depending on how you answer, that might be what your future holds. It might be that you want to be an astronomer, or it might be that you want to be an engineer. So, with that in mind, the do-it-yourself spacecraft is now a thing we can talk about. Starting in about 1999, some folks at Stanford and Cal Poly came up with this idea of a 10 centimeter by 10 centimeter cube. It's roughly the size of this plastic box here. This plastic box itself is not a CubeSat, but it's about this size. That's really small, right? Sort of a grapefruit-sized spacecraft. You can't do much with that, they said. So it might be good for educational purposes. You can teach kids a little bit about electronics and structures, and that's all well and good. It turns out that the world was waiting for an open source specification for how to build something like a spacecraft. Every satellite, every probe, every rocket built up to the late 90s was unique. It required a lot of work, expertise, creativity to make these rockets or these spacecraft successful. Now, you can buy these parts on the internet. They're almost all the same parts all the time. They launch inside this spring-loaded device here. It's called a P-pod. I'll show the video again. All you do is load your CubeSat into the little pod. The idea is that 3 of them fit in a pod, like 3 peas in a pod. Anyway, this shows our loading a triple-size CubeSat into this pod for launch. So that would go on a rocket, the rocket would take it to space, and it pops it out under the action of some springs. It's very, very simple. It's surprising how much simplicity helps when you're trying to change the world. So this has changed the world, thanks to Bob Twiggs, Jordi Puig-Suarez, and a number of other people who designed this basic idea. This CubeSat, or this kind of thing, is now a relatively cheap way to get to space. High school students have built these CubeSats. One of them, the first by a high school group at Thomas Jefferson High School in Virginia, sent text messages back to the Earth. So there's maybe not much that they have done with it yet, but there are very exciting things on the horizon people are doing with CubeSats. And maybe more to the point, they are the most commonly launched type of spacecraft today. You might think of weather satellites or defense satellites or who knows what. No, CubeSats are the most commonly launched type of spacecraft. So here's, I'm taking a break from talking for a second and ask my first trivia question. Does anybody know the name of the rover I was just talking about that's on Mars now and operating? I think you were hang on it first.
Discovery.
That is the name of something else, but not that particular. You're close. You're very, very close. I think you were next.
Curiosity?
Curiosity. Would you like to win this official NASA sticker?
Why not?
All right. You can go on your parents' windshield or anywhere else you want. You be next. So there's this phrase, commercial off the shelf. It means I don't have to go to NASA or, I don't know, Boeing or Lockheed Martin or Northrop Grumman or name your aerospace company to buy the parts for these CubeSats. You can get them from the internet, from half a dozen companies that sell the whole spacecraft or some pieces. These guys sell the attitude control subsystems, for example. You can buy all the parts online. It's a little expensive. It probably costs you, I'm going to say, the cheapest CubeSat you could probably build on the order of a couple $1,000s. It's a little more than you probably have with you in cash right now, but still, it's conceivable that a private individual or a group of students could build a spacecraft for that kind of money. Now, it also costs a lot of money to launch these things, but NASA will do it for free for you. That's another neat piece of news. This is what I was saying before. If you look at the history of these things, back in 2010 even, not that long ago, there were only a few dozen CubeSats being launched, and even then that's kind of a lot. Now we're up in the multiple hundreds, maybe 400 or 500 of these individual spacecraft every year. That's astonishing. That's a lot of hardware going into space. And mostly, they're not made by the large aerospace companies or even NASA. They're made by people like these hipsters here, my friends at Planet Labs. They are former NASA employees. Robbie here used to work for me at NASA. A few others wanted to work for NASA, but they were not allowed to, so they said, fine, forget you, I'm going to build my own spacecraft, and they did. Now Planet Labs builds these so-called flocks of doves. Each one is a dove. Each one is a so-called 3U CubeSat, so triple the size of a typical CubeSat. They are meant to do Earth observations, imagine something about 3 times that size. That's a stack of them right there. They have a process where, in their little factory consisting of a few dozen people in San Francisco, they can build one spacecraft every 6 hours, which is kind of amazing, given that most large science spacecraft and defense spacecraft take about 12 years to do the same thing. If you're fortunate to get a job working on large science spacecraft like the James Webb Space Telescope, you might find yourself doing 1 or 2 of them in your career. If you work on CubeSats, you might do hundreds. And that's an interesting possibility too. Keeps you interested. So this is a little publicity video from Planet Labs. It shows up close. The telescope, the solar panels. Sorry about the quality there. It doesn't really do that in real life. One of my first master's students at Cornell designed the solar panels for these spacecraft. In fact, there's quite a few Cornell students now working at Planet Labs. Sorry about that shakiness, I don't know what's up. The constellation that they plan to put in space, in fact they've already got part of the way toward it, will take pictures of anywhere on the Earth once every hour or so. So imagine that you wanted to watch your crops over the course of the day, track whales in the ocean, look for people violating treaties, or whatever it is that might be of value, scientific value, commercial value. Planet Labs has a solution for that through that capability. So it'd be like going onto Google Maps or Google Images and seeing an update of any place on Earth once an hour. The resolution is not fine enough to track people, so they can't spy on people that way, but it's good for science. In fact, it's irreplaceable for science. There are things they can do thanks to CubeSats that we can't do any other way. This shows, this is a video, an actual video from actual space, not as pretty as the one we just saw, but real video is not as pretty as the rendered stuff, showing a bunch of individual CubeSats from Planet Labs deploying from the Indian, that is to say the country India, PSLV, the launch vehicle that they build. So not only our CubeSats something that level the playing field for individuals to participate in space exploration. It's also an international activity. It blurs the boundaries among countries in a way that I think is positive. So here we have an Indian launch vehicle launching American-made satellites built by a number of folks who are not U.S. citizens working in California to make it all happen. It's an international effort that's been very successful. And again, I think it's a good story to tell. So this is one version of how to build your own spacecraft. You build these CubeSats. And as exciting as that is, you're still talking about many thousands of dollars to put one of these into space. So let me tell you a story about what happened in 2011. I was minding my own business, and a friend of mine from Lockheed had just discovered a problem with a payload that they were about to send to the International Space Station. It's this box right here. It's called MISSY-8, Material Science Experiment on the Space Station. It's an acronym, MISSY. So MISSY-8, one of the experiments didn't work, and they had to take it off. So his company, Lockheed Martin, had to deliver this object to the space station, but it had a big hole in the middle. It looked embarrassing. So he said, do you have anything in your lab that we could fly so we don't look like we have a big old hole in our experiment? And I said, sure, of course we do. So then I called my lab group together and said, do we have anything that we could possibly fly for Justin here? Because he really needs to put something on the space station. And we came up with an idea that we've been thinking about for a while, and we have built versions of, but in about a week, this student here, Zach Manchester, who's now a faculty member at Stanford, and a couple of other students that I'm supervising, they put together this little circuit board. This is what we call a sprite. And I've got one in a box here. At least this is the version which we have since made much more sophisticated and sent to space. So I'll start with you. You can hand that around. Just keep the plastic close because it's kind of delicate. That green circuit board is a satellite. It has solar cells. It has a processor for computation. It has a radio. In fact, the radio is for car key fobs. You press the button to unlock your car. That's the transmitter that we use to transmit from space. They cost like $1, so that's the right price. Anyway, we built this sprite, so-called, put 3 of them on the space station, and for the next 3 years, they got cooked and beaten up in the space environment and worked, continued to work for 3 years. They even came back, and we have them now at Cornell. They're all brown and crispy, but they do, in fact, still work. It's a proof that all this commercial off-the-shelf hardware, the stuff that's in your Wii controller, your Xbox controller, the stuff in your smartphone, that is good enough for space, it turns out. In fact, a lot of that hardware is better than the hardware that NASA uses for a variety of reasons. So, if we can use that stuff that's been developed, the technology's been developed for years now to meet the needs of the commercial cell phone industry, we can do better than NASA's been doing. This is a picture, therefore, of the smallest spacecraft, the Sprite, on the largest spacecraft, the space station, which I think is kind of a cool story to tell. I'm also going to pass around this guy here. So what you're seeing there is the Sprite in its operational form. That we've since launched a number of those. This is the next generation, which not many people have seen. This is a single integrated circuit that has all of that stuff on it, plus a number of other cool things. It has a laser on board for laser-based communications. It blinks a light, you pick up that data. And it has some other cool stuff, so I'll pass it around, you can look at it. When I say you can build your own spacecraft, I really mean for about $40 in parts, you could put this together, and this is a spacecraft. So the plans for this are all online. I'll give you the link later. If you'd like, you can go online and get your own design for these things, download the software, build it yourself, and you then have a spacecraft. Getting it launched is another story, but I can tell you that.
Have you ever dreamed of having your own spacecraft? I'm Zach, a grad student in aerospace engineering at Cornell, and I want to fundamentally change the way that people think about and take part in spaceflight. Since the beginning of the space age, if you weren't an astronaut or an engineer or a scientist, your only way of taking part in spaceflight was by watching it on TV and reading about it in books and magazines. Well, I want to change that. And that's why for the last several years I've been working on Sprite, the world's smallest spacecraft. By shrinking the spacecraft, we can launch many of them together in the same launch slot, and we can split the cost of that launch many ways. In fact, we can get the cost of launching a single Sprite into orbit down to only a few $100s. Now here's where I need your help. I want to launch a satellite called KickSat that's designed to carry hundreds or even thousands of these tiny sprites into orbit. To build that satellite, I need to raise at least $30,000. By sponsoring KickSat, you'll be directly contributing to the future of personal spaceflight. Plus, what better way of showing off your uber geek credentials than by having your own spacecraft? If you sponsor a sprite, you'll get to name it and specify the text message that it'll transmit from orbit, like your initials. So, thanks for checking out my Kickstarter page. Now let's go kickstart the personal space age.
So as Zach said, that was part of a Kickstarter campaign. Who's heard of Kickstarter? You get to win a thing. Okay, I think you've already won something. I think your hand went up. You want to define Kickstarter for us for a shuttle dash?
Sure. Oh, define it?
Yeah.
It's a way of raising funds beyond your immediate connections. Basically, it's an online fundraising thing
yeah.
where people buy in and go, yeah, that sounds interesting, and I'm gonna buy into that.
Sure, so it's crowdfunding they call it, right? So, here, I'll frisbee this to you. Ready?
Yep.
Oh, very close. All right. Thank you for answering my question. So Kickstarter was the basis for KickSat, hence the name. Zach's plan was to raise $30,000, as you heard. He raised almost $80,000. And in the wake of his success came a large number of other Kickstarters that also were successful, building little CubeSats with Kickstarter funds. That was back in 2011. We tried another one of these just last year, and it completely failed. I think the time has passed, but at least we caught it on the upswing. What's your question?
So, did he add extra KickSats to the spacecraft?
Yes, well,
With
extra
that?
sprites, yes.
Yeah.
Yes, he did. So in fact, KickSat 1 launched in April of 2014, and it was almost successful. I'll show you a couple other things, and I'll answer the question this way. So sorry again for the video, but this is a test in our highly precise laboratory where the 3U CubeSat spits out those individual sprites. That is a successful demonstration of the test. You're worried about these things? Remember, they're only a few bucks each, okay? So it's okay to break a few satellites. Which brings up an interesting point. Rather than thinking about something like the Space Shuttle or the James Webb Space Telescope or any of the other exquisite platinum-covered spacecraft that we think of in the context of NASA, which are wildly successful and wonderfully beneficial for our knowledge of science and so forth, rather than thinking about that, let's think about what happens if you have so many spacecraft that you don't mind if a few of them fail. Well, you can define mission success in a different way. Rather than having one spacecraft be successful, all you need is a certain number to be successful. Let's take, for example, what if I want to send some of these to the moon? I suppose I could spend millions of dollars coming up with a lander and slowly land it down to the surface. Well, why would I do that for something that costs 10, 20 bucks? Instead, what if I just throw them on the surface of the moon? They will hit the surface at, on the order of 2 kilometers per second. Super fast, like a mile per second, which is disastrously fast. But this next week, we're going to be testing some of these things at the University of Maryland. We think at least 1 to 10% of them would survive that impact. Even if only 1% survives, well, let's say I send 1,000 to the moon, I still get 10 back. 10 of them land on the surface. So if my mission can be successful with 10 of these, I can use the statistics to buy down the cost that I would otherwise have to spend to land these on the moon the normal way. So you can make the numbers work for you. Another way to say it is, I no longer care about failure. Failure is an option. And in fact, I would embrace it because it allows me to spend much less money on the hardware. I will point out 3D printed spacecraft because 3D printers are cool, right? This entire spacecraft came out of a 3D printer. So not only can we make these things inexpensive, we can also make them in ways that NASA has not done before. So again, sorry for the crummy video here, but one thing I can tell you is that this deployment didn't happen on KickSat 1. The story goes something like this. About a week before launch, NASA called up our lab and said, it turns out there's going to be another spacecraft coming up behind yours. We don't want the chaff, they meant our spacecraft, they don't want our chaff to run into this other spacecraft. So they said, you need to delay the deployment by about 16 days. So Zach dutifully went to the launch site, They opened up the rocket, he pulled out his spacecraft, he reprogrammed it, changing the timer that was half an hour to 16 days. Buttoned it back up, and away we go. The spacecraft was never designed that way, but in fact it worked fine. So SpaceX launched it. It separated on April 18th, 2014. It did its thing, counting down 16 days. 12 days in, there was a radiation anomaly from the sun, one of these coronal mass ejections that spits high-energy particles toward the spacecraft. Zach's design worked perfectly. Everything shut down on the spacecraft because of the high-energy stuff that was going on, and it started back up again, which was great. But because he had to program this at the last minute, the timer started from scratch again. So now we're starting to count down again, starting at 16 days. And before it reached 16, 2 days before it reached 16, the whole thing re-entered. It turned out the spacecraft that was supposedly coming up behind ours never launched anyway. We could have just let this thing go and it would have been fine. But I'm not bitter because we got to try it out and it was successful. So we're going to launch an identical one of these called Kicksat-2 in another 6 months, again with NASA's help. So NASA's been very supportive of this whole thing. It's unfortunate that the world conspired, I guess, to make that fail. But the good news is, because of how inexpensive this is, it is possible to build your own spacecraft and try again. If this were something like the Apollo mission, forget it. This kind of failure would have been a disaster. If it's the James Webb Space Telescope, huge telescope meant to fly between the Earth and the Sun, you can't build another one of those. Just not going to happen. But there are lots of exciting things we could do with these sprites. We could send them, for example, to this moon Enceladus for another prize. What planet is Enceladus a moon of? Yes?
Jupiter?
Maybe not. Close.
Saturn?
Well, you don't get to guess twice, but so this is, there you go, space shuttle.
Thank you.
You're welcome. All right. Speaking of space shuttles, here's another trivia question. There's been a number of space shuttle missions. They're all numbered, STS something, like STS-1 was the first one. There's been over 100 of them. If you can tell me how many space shuttle flights or launches there have been, you will get a bookmark commemorating the very last one. Yes?
135.
135, yes, 135. STS 135 was the last one.
I actually saw that launch, the last one.
You did?
Yeah,
You
we
were
were in
there first?
Florida. Yeah, well, we were in Disney World. It was good.
What did you think?
So. It was very cool. We didn't think we could see it, but nice early in the morning.
It's remarkable, isn't it? Lights up the entire sky.
Yeah.
All right, so since I'm giving away stuff, I've got one more. This is for anyone younger than 14 in the audience. This is the mission before last, the penultimate one. What is the number of this mission? You already answered the question. Yes?
134?
Yes!
Is this
Got
a
it.
trick question?
No, but it's clever of you to think I might be trying to trick you. There you go. STS-134 is the mission that launched our first sprite to ISS. So that's why I have a bunch of those stickers. So there you go. Now you have an STS-134 sticker. I'm sure you would have said the same things. Thank you.
Are they at all concerned about how much stuff is up there? They used to track all of the...
Yes, okay, so this is a
Space
great
objects.
question. The formal word for that is space debris. Or they call it space junk sometimes, right? The question is whether all these little spacecraft are going to clog up space and represent danger for whatever human missions or commercial missions or anything else. It's a great question and it's an important issue. The sprites, though, have a special feature to them. They are so lightweight for their surface area that atmospheric drag brings them back into the atmosphere after about 2 days. So in fact, they clean up after themselves based on the very physics of their spaceflight. It's, in other words, the cleanest spacecraft out there because even CubeSats stay up there for months at a time. Typical larger spacecraft in low Earth orbit could stay up for many months, maybe even years at a time. And there's even a rule that the Air Force has put in place that you must deorbit your spacecraft within 25 years. We meet that by a factor of 1,000 or so. So we're okay. Anyway, the cool thing about these CubeSats is that they do clean up after themselves. It also means a couple of other interesting things. One of them is they are almost lightweight enough to serve as a parachute, which means they can almost survive re-entry. So you could do science on the way down. To make them survive re-entry, they cut the mass in half, add about 1 more centimeters worth of space, and then in fact they would be lightweight enough to float down through the atmosphere. They would never get so hot that they'd burn up, and you could take pictures or temperature data or look for pollution or even microbes in the upper atmosphere. You can do all this in that space between orbit and the atmosphere, which no one has ever taken data before. It's too low for satellites. It's too high for aircraft. But these could actually populate that area briefly, for maybe 15 minutes. So that's an interesting prospect.
So I have a question. These are the sprites, the one in the box,
Clear
right?
plastic boxes, right?
And the newer version looks much smaller.
Right. So the very small version is actually for an entire of the other project. And I'll talk about that next. So this one is not enough to probably. You need something larger surface area, more like a parachute. But it can be done. So the next generation we're building, I don't have any pictures of that, but the next generation is actually meant to be about 5 centimeters rather than 3.5. So it's a little bigger, and that's just enough to put it over the edge so that the electronics would not get hotter than about 80 degrees C, so that's pretty good. It's still hot, but it would probably survive.
Yeah.
Could I ask a question?
Please.
So you talk about spacecraft, I think about propulsion and attitude control. Do these little sprites have attitude control? Because you mentioned laser communication, so they must be pointable.
That's a wonderful question. So at the risk of, let me see, how can I answer this question and do it the justice it deserves and not lose the folks with the hats in the audience? Let me see. I'm going to suggest that, all right, so any spacecraft you have is only useful if you can point it somewhere, right? Take a picture, or maybe put it in a place and take measurements. In any case, you've got to govern its position or its orientation somehow. So the question is, can you do that with these little tiny spacecraft? What's the means by which that can happen? One answer is this. Every one of these sprites has inside it a magnetic torque coil, so like an electromagnet. When you put power on the electromagnet, it produces a magnetic field. The Earth has a magnetic field. So the sprite can lean against the magnetic field of the Earth and tilt in response to whatever criterion we give it. So if we say, go look for the sun or point north, it can slowly work its way there. We've never demonstrated that in space, but we have done it on the ground in a bucket of water. So you can turn on the little thing and have it find the sun through a magnetic interaction with the Earth's magnetic field. So yes is the quick answer to the attitude problem. That's the orientation problem. How would you change the position? You do that by changing the attitude. So you take advantage of the fact that there's drag in the upper atmosphere, and if the sprite is sort of facing this way into the wind, it drags more than a sprite going like this. So you can, by changing the attitude, also change the forces acting on it a little bit, not a lot. Right now, we don't have any other propulsion system that could take it beyond Earth orbit. It'll only ever go down. That's kind of intentional. We actually don't want to pollute space with more debris, so the fact that these re-enter on their own is kind of a good thing. We are working with a small company, though. It's a startup that's building a rocket, not a traditional rocket. It's actually called a light gas gun. This rocket would explosively propel a sprite or something like it, maybe even a CubeSat, into orbit using technology we've understood for a long time. It needs to get going about 7,000 or 8,000 meters per second for that to happen. And therefore, these sprites have